What's up? What's up? It's your man, Jimmy Chan. All right, so we're talking about graphs of polynomial functions. So you're welcome to read all of this in terms of steps, but I'm going to go ahead and show you right off the bat with an example. So let's say we're given this polynomial function. Question is, how can we graph this? Well, right off the bat, I can see what the roots are or the zeros are and also their multiplicity. So typically I would go ahead and if I was to find the x-intercept, the x-intercept, I know that y is equal to 0. So I will have 0 is equal to x plus 1, x plus 3 squared, and x minus 4. Right? Since that's equal to 0, I'm going to set each of those factors equal to 0. So what I'll get is x equals -1. And in this case, because the power is to the first power, I know this is odd, which means it goes through the x-intercept. This is x equals -3. This power is 2, which is even. So I know that this is even. So this is going to bounce off of the x-intercept. And this is going to say x equals 4. And since this power is odd, or 1, I know it's odd multiplicity. Okay? So that's my x-intercept. What's my y-intercept? Well, y-intercept is when x is equal to 0. Okay? So if x is equal to 0, I have y equals to 0 plus 1, 0 plus 3, squared, and 0 minus 4. So my y is going to equal to 1 times 9 times -4. So my y is going to equal to -36. Okay? So it's pretty steep overall as my y-intercept. Okay. Let me see. Let me work this thing out as well. So let me go ahead and draw a line right here. Some of the things I've already found. And let's go ahead and work this out. F of x, I'm going to rearrange that. It's going to equal to x plus 1 times x minus 4, and then the x plus 3 squared. The reason is because I want to go ahead and FOIL this, or double distribute, and also FOIL and double distribute this as well. Okay, so when I do that, I'm going to get x squared minus 3x minus 4. And here, when I FOIL this out, it's going to be x squared plus 6x plus 9. So I got to go even further. So let's go ahead and do this math here. And I'm going to do it over here to the right, because what I'm going to do is I'm going to go ahead and distribute this x squared. Oops. Okay, I'm going to distribute the x squared, and I'm going to get, excuse me, x to the 4th plus 6x to the 3rd plus 9x squared and let's now distribute the -3x here. I'm going to get a -3x to the 3rd minus 18x squared minus 27x. Okay. Distribute -4, I get -4x squared minus 24x minus 36. So what do I have here? Add this, I got x to the 4th plus 3x to the 3rd minus 13x squared minus 51 minus 36. So I could have got this y-intercept right here instead of plugging all those in. I could have got it right here. Oops, I forgot the x, did I? I did. There we go. Right, because this would have been 0, 0, 0, 0, and then left with negative 36. Right? So this is going to be the f of x. So with that being said, what do I know? I know that the degree is a 4. So turns is 4 minus 1, so it's equal to 3. So I have 3 turns. Okay? All right, with that being said, let's take a look at what the graph might look like now. Stickers. Oh boy. There's not going to be a sufficient graph. Let me go ahead and do this here. And I'm going to take this out. There we go. All right. So I have my zeros at -1, at -3. But this is even, this is odd, and at 4. And this is odd, right? I have my y-intercept at -36, so it's somewhere down here. I know it's not drawn to scale, but it's okay. All right. So, actually, you know what? Let's do it this way. Let's bring this. Let me see. What if I called these? Because these don't have, I mean, the x is in scale, right? So let's go with the y value, like not in scale, right? Let's go by 6s, right? -6, -12, -18, right? -24. So 1, 2, 3, 4, 5, 6. So it'll be right here. It'll be -36. Okay. So now notice that from here to here, going through this point, I have to go down and back up, right? The question is, how far down does this go before it comes back up? All right. So that's why I gotta be careful of. All right. So that's number 1. So now, because of this x-intercept and where this y-intercept is, I know that this is not going to go this direction and then come back down to go through this and then come back up to go through this because I don't have any other x-intercepts. So for that, I know I'm going to have something, let's say, like this. Okay, for that, let's say I got something like this. Okay, let's say for that, we got something like this. Okay, it doesn't like my parabola. How about this? There we go. Okay. Took me a few tries. All right. So now this is not going to be necessarily right? It's not necessarily symmetrical. I don't know actually how this is going to be in terms of symmetrical wise. Right. But I do know that it has to go through this point, and this point. And I also know that this has to go through. So let me go and go through. So something like that. Okay. So that's one turn, right? And then I'm going to have to kind of go over and get over here. Ooh, but wait. I gotta duplicate that. Also, let me bring this, delete this. I know that this is gonna bounce off of this also, right? Oh boy. This doesn't look very nice, does it? Ooh, this doesn't look very nice at all. That looks okay, right? So now the other thing I forgot to talk about is because this degree is a 4, I know that this is even, and A is positive, so I know that this is going to go, my end behavior is going to both point up. Right? So as you can see, this is both pointing up. So I do know that as well. So that's the reason why I would know that I was trying to focus on those two pointing up. So with that being said, I have 1, 2, 3 turning points, which I needed 3. And now that I look at this doesn't look like it's very, there we go. Whoa. Yeah, I need this out a little bit. Let me do that first and then bring this back. There we go. So there goes my graph. That's what it should look like. All right. So again, just as a review, right? So what did we do? We went and found the x-intercept so that we found the zeros. We see that this power is a 2, so it's even, so it's going to bounce off of this. But since the powers here are 1, which is odd, that means that it's going to go through those 2 points, -1 and 4. And then I found my y-intercept, so I plotted that. I worked the problem out so I know what the degree is, how many turns it is, and because it's a, because the power is a 4, right? So I know it's even. So I know that the end behavior is this. I know that the A is positive, so it has to point up. If it was negative, it will point down, like a frowny face. So I knew that the end results are going to look something like this. So I plot those points. I know this is going to bounce off. I just don't know if it's going to bounce off from above or from below. I didn't know if this was going to go through this way or this way, or this way, right? However, because of the y-intercept, I know that from here to here, it had to go through the y-intercept to come back up to here so that it would create that first turn. But when I come through here, I somehow got to get back here. So that means I got to take that turn again to come back and grab this and then bounce off to go upward. All right. So the graph should look something like that. And I hope that helps. And then the next thing is, what if we had been given a table of results, which X and Y, right? So there's a monthly cost in thousands of dollars of printing X thousand of brochures at a marketing company. And we want to find the cubic regression for this. So what I did here was put all the steps down for the TI-84. And also, so at the end result, once you find this, when you type in cubic regression, it automatically puts in the ax to the third plus bx squared plus cx plus d, so that you know what the a value, the b value, the c value, and the d value. This r squared value, as it gets closer and closer to 1, that means it's a better and better fit to the graph. So this would be my cubic equation for these particular points, all right? But I also showed what it would look like if it was on Desmos. So on Desmos, I showed you that we want to hit the plus table and enter the table. It will show me the dots as long as your scales are correct. And in the second box, you're going to type this in. Because this says Y1, we want to use Y1. Since this says X1, we want to use X1. And then we'll see our A, B, C's, and D's. And again, the R squared is very close to 1. So it's a pretty darn good fit line. So there's the best fit line that this is showing, which is this equation right here. Okay. So from there, I can also see that the A, B, C, and D are right here. All right. So I hope that helps. If there's any questions, please let me know. See ya. Bye. And please, I would tell you whichever calculator you decide to use, please practice this and see what it looks like. In fact, go ahead and plug this equation in and see if this looks good. And if so, you can always plug whatever you want in here. Before you hit graph, go ahead and play with what you think it might look like, and then see if the graph looks like it or not. All right? I hope that helps. Talk to you later.